Linear and nonlinear functions, lesson 14 notes. Nonlinear functions are functions whose graph does not form a straight line. So if there's any type of curve or break or anything like that in the graph, then it would be a nonlinear function. We're going to look at 6 different types of nonlinear functions. I'm going to write down equations that would be examples of those types of functions. I'm going to show you pictures of them. You're going to write down, you're going to try to at least attempt to draw what they might look like and write all of this down. But I want to tell you, don't worry about needing to know this for the test. I just want to introduce you to different types of nonlinear functions that you will become more acquainted with when you get to algebra and algebra 2. Okay, so I'm going to start with the quadratic function. So the quadratic function kind of looks like a U. It's called a parabola. That's what a quadratic function looks like. All right, so if you come over to this one, notice how there's a bunch of them that are opening upward and a bunch that are opening downward. So let's look at the top one. The innermost one, this one right here, that is 3x squared. This one is 2x squared. Then this would be x squared and 1/2 x squared, and then 1/3. So 1/3 x squared, sorry. Notice how that when the coefficient of x, that's the number in front of x, when the coefficient got smaller, the parabola got wider. The smaller the coefficient, the wider the parabola. And notice how all of these are pointing upward. Well, all of these down here are the ones that are pointing downward. What's the difference between these and the ones up above? These all have a negative coefficient. So in other words, if the coefficient's positive, it will point upward. If the coefficient is negative, they will point downward. What do every single one of these have in common? They have an exponent that is a square. So for quadratic functions, the highest exponent will be a square. I can go back to this one, see how the highest exponent is a square. So let's go back to our... All right, so here are some examples. Y equals x squared, y equals x squared plus 3x plus 2, f of x equals negative 1/3 x squared, f of x equals negative 2x squared plus x. In a moment, you're going to pause your video and get all this written down. But I want to show you, here's an example of what they would look like. And each graph is a parabola. So take a minute, pause your video, and get all of that written down. Okay, now looking at these equations, what is something we haven't worked with before? That is this right here, okay? When you get up to higher math, algebra and algebra 2, sometimes instead of using y, they'll use the f of x instead. So off to the side, I would like you to write down that at times it is used in place of y. Pause your video and get that written down. Okay, so that is the quadratic function. The highest exponent is a square. So now we're going to look at cubic functions. Cubic functions. Notice how, well, let me go back up here a second. We call these the tails of the graph. So the tails here are both pointing upward. Here, the tails are both pointing downward. Well, if you look at a cubic function, one tail will be pointing downward while the other one will be pointing upward. The first one here eventually will be going upward. It might level off, or it might even have a wave in the middle of it, but in the end, the tail will be going towards positive infinity. Where this one has, the tail will eventually be going towards negative infinity. And the reason why is the lead coefficient. So A here is the is the lead coefficient. If the lead coefficient is positive, the tail will be going towards positive. If it's negative, it'll be going towards negative infinity. All right, what is the highest exponent for a cubic function? That would be a cube. So over here is another example. The highest exponent is a cube. Notice how the lead coefficient is a positive 1, so the tail is going towards positive infinity. And there is what that equation looks like written normally. Okay, so let's go back to our notes. Cubic function. Here are some examples. The highest exponent is a cube, and there are some drawings. Your drawings do not have to be perfect, just do your best. Okay. Next is a quartic function. Next is a quartic function. I like to call these the W functions because I think they kind of look like sloppy W's. All right. These are quartic functions. The highest exponent is now a 4. The highest exponent is a 4. Notice that both tails are pointing upward, or both tails are pointing downward. If you haven't figured out by it, like a linear equation has x to the first power. So when it's x to the first power, one tail will be going towards it, well, the tails will be going in opposite directions. But when we had the quadratic, the highest exponent was a 2, an even number. The tails were going the same direction. Then we had the cubic functions. The highest exponent was a 3. The tails were going in opposite direction. Here, this is a quartic function. The highest exponent is a 4, which is an even number. The tails are going in the same direction. So, if your highest exponent is an odd number, your tails will go in opposite directions. If your highest exponent is an even number, the tails will be going the same direction. So these, again, are quartic functions. All right, here are some examples. Again, the highest exponent is a 4, and here are some drawings to draw. Okay. I'm going to stop the video there, and I'll pick up with rational functions in the next video. If you have any questions so far on nonlinear functions, please let me know.